Hello and welcome to this video lecture. I am Jeyamuugan, Assistant Professor from the Department of Artificial Intelligence and Data Science, Tech Multitech, Dr. Rangaraj and Dr. Sagandala Engineering College. The topic for today's lecture is Internet of Things, and this lecture is part of the subject Embedded Systems and IoT. This presentation will provide a comprehensive overview of IoT, its application and its impact. I'm going to start from the understanding the fundamental concept of the IoT. Firstly, the Internet of Things refers to a system of interconnected objects. So think of it as a network where everyday items are connected and can communicate with each other. These objects have the ability to collect data and transfer it over a wireless channel, and importantly, they can do this without human intervention. So this means they can operate autonomously, gathering and sharing information autonomically. Expanding on that, IoT describes the network of physical objects. We call them things that are embedded with the sensors, software, and other technologies. These embedded technologies are what allow these objects to connect and exchange data with other devices and systems over the internet. So it's not just about connecting to the internet, but also about the ability to gather data through sensors and then share that data. Finally, and most importantly, IoT enables us to analyze and act on data. So this is where the real value lies. By collecting and analyzing data from these connected devices, we can gain valuable insights. So these insights can then be used to facilitate the decision-making process. In essence, IoT provides the data and we use the data to make smarter, more informed decisions. The key is that insights from the IoT help transform businesses and lower cost. So this is achieved through the availability of reliable real-time data. Instead of relying on estimations or delayed information, businesses can make decisions based on up-to-the-minute data collected from the connected devices. One major benefit is the reduction of wasted materials. For example, sensors on a production line can detect defects or inefficiency in real time, allowing for immediate adjustments and preventing the production of faulty goods. So this minimizes waste and saved resources. IoT also facilitates streamlined operational and mechanical process. By monitoring equipment performance and identifying potential issues before they lead to breakdown, businesses can optimize maintenance schedules and improve overall efficiency. So this proactive approach reduces downtime and ensures smooth operations. Finally, IoT enables businesses to explore expansion into new lines of businesses. The data collected from the connected devices can reveal new customer needs or market opportunities. For instance, a company might use data from smart home to develop new services or products tailored to specific customer segments. Now let's see the fundamental process of how IoT actually works. The first stage is sensors and devices. So these are physical things that collect the data from their environment. So think of them as the eyes and ears of the IoT system. They could be anything from temperature sensors in a smart home to motion detectors in a security system, or even complex machinery with embedded sensors on a factory floor. So the primary function here is collecting data. Once the data is collected, it needs to be transmitted. This is where the connectivity comes in. The stage involves sending data to the cloud. This can be done through various means such as Wi-Fi, cellular networks, Bluetooth, or other communication protocols. The key is to securely and efficiently transfer the data from the sensors to a central location for processing. The next stage is data processing. The raw data collected from the sensors is analyzed and transformed into meaningful information. So this involves making data useful. This might include filtering out noise, aggregating data, or applying algorithms to identify patterns and trends. The goal is to extract valuable insights from the data. Finally, we have the user interface. So this is how the processed information is presented to the user. It's about delivering information to the user in a way that is understandable and actionable. So this could be a dashboard on a smartphone app, a report generated by a computer, or even an automated action triggered by the system itself. The user interface allows us to interact with the IoT system and utilize the insights it provides. Now, let's see the architectural framework that makes it all possible. At the base of the architecture, we have things, sensors, and controllers. So this represents the physical layer of the IoT system. So these are the things we talked about earlier. The devices with the sensors that collect data, controllers access the brains processing data locally and controlling the operations of the things. So this layer is crucial for data collection and initial processing at the source. The next layer is gateways and data acquisition. So gateways act as intermediaries collecting data from the sensors and controllers and transmitting it to the cloud or data center. They often perform initial data processing and filtering to reduce the amount of data sent to the cloud. Data acquisition involves the process of gathering data from various sources and preparing it for transmission. The edge analytics is where we move beyond simple data collection. So this layer involves processing and analyzing data closer to the source at the edge of the network. So this allows for faster decision making and reduces latency. For example, a smart factory might use edge analytics to detect abnormalities in real time and trigger immediate actions. Finally, we have the data center or cloud platform. So this is where the vast amount of data collected from the things is stored, processed, and analyzed. Cloud platforms provide the necessary infrastructures and tools for data management, analytics, and application development. So this layer is responsible for long-term data storage, complex analytics, and generating insights that can be used for decision making. Here we see the sensors and controllers collecting the data. The data is then transmitted through gateways to the cloud platform. The cloud platform provides the necessary infrastructure for data processing and storage. Finally, the processed data is made available to users through various applications and interfaces. And here in the layers, at the base we have the perception layer. So this layer is characterized by the use of various digital devices. Think of these as the sensors and actuators in a general IoT model. In a learning context, these could be devices like smart watches, tracking activity, tablets used for interactive actions, or even environmental sensors in the classroom. The key function here is to collect information and request information from networks. Essentially, it's the interface between physical world and the digital system. The next layer is the network layer. So this layer is composed of online networks that help transfer data. This is where the communication protocols and infrastructure come into play. It's responsible for securely and efficiently transmitting the data collected by the perception layer. to the higher layers for processing and analysis. This could involve Wi-Fi, cellular networks, or other communication technologies. Moving up, we have the application layer. This layer is responsible for distributing the learning content. This is where the user interacts with the system. It could involve learning management systems, educational apps, or online platforms that deliver courses and materials. This layer translates the data into actionable information and provides the interface for learners to access and utilize the content. And finally, at the top, we have the data management layer. So this layer collects data from learners and provides them with the learning data. This is where the analysis and insights are generated. It involves processing the data collected from the perception layer, transmitted through the network layer, and used by the application layer. This layer provides valuable insights into learner behavior, performance, and engagement, allowing for personalized learning experiences and continuous improvement. And this diagram visually represents the flow of data and information within the IoT architecture for learning. So it starts with the perception layer, collecting the data from devices, moves through the network layer for transmission, is utilized with the application layer for content delivery, and finally analyzed and managed by the data management layer. And at the base, we have the sensors and actuators. Either it can be wired or wireless. So this is the physical layer where the data collection begins. Sensors gather the data from the environment, and actuators can perform actions based on the received data. So these can be connected via wired or wireless connections depending on the application and environment. So think of these as the things, as we discussed earlier, the devices that interact with the real world. And moving up, we have the sensors and actuators, data acquisition system layer. And this layer focuses on processing the raw data collected by the sensors, and it involves tasks like a data aggregation, which combines data from multiple sources, analog to digital conversion, which converts analog signals to digital data, measurement and control. So this layer prepares the data for transmission and ensures its accuracy and reliability. The next layer is edge IT. So this is where edge computing comes into play. Data is processed and analyzed closer to the source, at the edge of the network, rather than sending everything to the cloud. So this layer performs analytics and pre-processing, reducing latency and enabling faster decision making. For example, a smart factory might use edge analytics to detect anomalies in real time and trigger immediate actions. Finally, we have the data center or cloud. And this is where the vast amount of data is stored, processed and analyzed in the cloud or the data center. It involves analytics for deeper insights, management of data and devices, and achieving for long-term storage. This layer provides the infrastructure for complex analysis and data visualizations and application development. And let's explore the key factors that are driving into this rapid expansion of the IoT. So this slide highlights 5 crucial elements that are fueling the growth of the IoT. First, we have falling sensor cost. So actually, sensors are the fundamental building blocks of the IoT, and their decreasing cost has made it more affordable to deploy them in a wide range of applications. So this has led to the proliferation of connected devices in homes, businesses, and industries. Next, we have falling costs of data collection and storage. So as the amount of data generated by the IoT devices increases, the cost of collecting and storing this data become more manageable. This is due to advancement in cloud computing and data storage technologies, making it economically feasible to handle massive data volumes generated by IoT. Another key factor is widely expanding internet connectivity. So the availability of high-speed internet and the expansion of cellular networks have made it easier to connect devices and transmit data. This widespread connectivity is essential for the seamless operation of IoT systems. We also have increasing computing power. The advances in processing power have enabled devices to handle more complex tasks and analyze the data locally. So this has led to the development of more sophisticated IoT applications that can perform real-time analysis and decision making. Finally, we have increasing smartphone and tablet penetration. Smartphones and tablets have become ubiquitous, providing a convenient interface for users to interact with the IoT devices and access data. This has made it easier for individuals to adopt and utilize IoT technologies in their daily lives. These factors are interconnected and reinforce each other, creating a powerful engine for IoT growth. As these trends continue, we can expect to see even more innovative and transformative applications of IoT in the future. Now, let's focus on the tangible benefits that IoT brings. So the slides outlines 5 key advantages of implementing IoT solutions. The first advantage is efficient resource utilization. So IoT enables us to optimize the use of resources by collecting data and making informed decisions. For example, smart grids can optimize energy distribution and smart agriculture can optimize water usage. So this leads to reduced waste and improved sustainability. And second one, IoT helps to minimize human effort. So by automation and remote monitoring capabilities, reduce the need for manual intervention. This frees up human resources for more strategic tasks and reduces the risk of human error. As we see in the small circle below, this is further explained by the phrase IoT interact and communicate. So this interaction and communication often replaces the need for direct human involvement. And another significant advantage is save time. The real-time data and automation streamline processes leading to faster decision making and improved efficiency. For instance, predictive maintenance can prevent equipment failures, saving time and resources. The smaller circle below further explains that reduces the human effort which inherently saves time. And the next one, that IoT significantly enhances data collection. Sensors and connected devices can collect vast amount of data that would be possible to gather manually. This data provides valuable insights for analysis and decision making. As we see in the smaller circle, this is explained by the word automatically. IoT devices automatically collect data, providing a more comprehensive and accurate picture of operations. Lastly, IoT can improve security. So this real-time monitoring and alerts can detect and prevent security breaches. For example, smart security system can detect unauthorized access and trigger alarms. The smaller circle below explains this as a secure and efficient. IoT, when implemented correctly, can provide a more secure and efficient way to manage assets and operations. So these advantages demonstrate the transformative potential of IoT across various industries and applications. By leveraging the power of connected devices and data analytics, we can create more efficient, sustainable, and secure system. And however, it's important to acknowledge that there are also potential drawbacks and challenges associated with its implementation. The first major disadvantage is security network attacks. So as the number of connected devices increases, so does the potential surface for malicious actors. IoT devices often have limited security features, making them vulnerable to hacking and exploitation. This can lead to data breaches, system disruptions, and even physical harm. Another significant concern is privacy. IoT devices collect vast amounts of personal data, raising concerns about how this data is being used and protected. There is a risk of unauthorized access, tracking, and profiling of individuals. And finally, we have the complexity of designing, developing, and maintaining of IoT systems. That IoT involves integrating various technologies, protocols, and platforms, which can be challenging and complex. Designing, developing, and maintaining these systems requires specialized skills and expertise. It's crucial to address these disadvantages to ensure the responsible and the secure deployment of IoT technologies. Implementing robust security measures, establishing clear privacy policies, and investing in skilled personnel are essential for mitigating these challenges. And we have discussed the numerous benefits and applications of IoT. Now, let's turn our attention to the challenges that organizations face when adopting IoT technologies. So this highlights 4 key challenges that need to be addressed for successful IoT implementation. The first challenge is the variety of hardware platforms available. While this variety enables a wide range of applications, it also creates complexity. Choosing the right hardware for the specific IoT deployment can be challenging, as different platforms have varying capabilities, compatibility, and security features. So this requires careful evaluation and planning to ensure the chosen hardware meets the specific needs of the application. The second challenge is data related. This includes data planning, data generation, and data collection. IoT devices generate massive amounts of data, and organizations need to have a robust strategy for managing this data. This includes determining what data to collect, how to store and process it, and how to extract meaningful insights from it. Without a solid data management plan, organizations risk being overwhelmed by the sheer volume of data. The third and most critical challenge is privacy and security. IoT devices collect and transmit sensitive data, making them vulnerable to cyber attacks. Organizations need to implement strong security measures to protect this data and ensures the privacy of individuals. This includes securing devices, networks, and data storage systems. Building trust with the users by demonstrating a commitment to privacy and security is essential for successful IoT adoption. Finally, we have the challenge of sustainability. The IoT devices are often powered on 24/7, which can lead to significant energy consumption. Organizations need to consider the environmental impact of their IoT deployments and look for ways to reduce energy consumption. This includes using energy efficient devices, optimizing data transmission, and implementing power management strategies. Addressing these challenges is crucial for realizing the full potential of IoT. By carefully planning, implementing, and robust security measures and considering sustainability, organization can overcome these hurdles and successfully adopt IoT technologies. We are now going to explore a very relatable and increasingly common applications of the IoT, that is smart home. The concept of the smart home revolves around using connected devices and automation to create more comfortable, efficient, and secure living space. One of the core advantages is control and monitoring. The smart home systems allows user to control and monitor various aspects of your home remotely. This includes lighting, temperature, appliances, and security systems. You can use your smartphone or other devices to manage these systems from anywhere in the world. Smart homes can also lead to cost and energy savings. By automating lighting and temperature control, you can reduce energy consumption and lower your utility. Your smart appliances can also be programmed to operate during off-peak hours, further reducing cost. There is also a positive environmental impact. By optimizing energy usage and reducing waste, smart homes contribute to a more sustainable lifestyle. This can include features like smart irrigation systems that conserve water and energy efficient appliances. Better security is another significant benefit. Smart security system can include features like motion sensor, security camera, and smart locks. These systems can alert you to potential security breaches. And finally, smart homes enhance comfort. Automated lighting and temperature control can create a more comfortable living environment. Smart entertainment systems can provide personalized experiences, and smart appliances can simplify everyday tasks. And in conclusion, smart homes offer a wide range of benefits, from increased comfort and convenience to cost savings and enhanced security. So as IoT technology continues to advance, we can expect to see even more innovative and transformative applications in the smart home space. And now we are now going to shift our focus to the transformative power of IoT in the agriculture sector. So this slide highlights the key applications of IoT in agriculture, showing how technology is revolutionizing farming practices. Agriculture is a critical industry, and IoT is playing a vital role in making it more efficient, sustainable, and productive. The first application is precise farming, also known as precision agriculture. This involves using sensors, data analytics, and automation to optimize farming operations. For example, sensors can monitor soil moisture, nutrient level, and weather conditions, allowing farmers to make data-driven decisions about irrigation, fertilization, and pest control. And another exciting application is agricultural drones. Drones equipped with cameras and sensors can now capture aerial images of crops, providing valuable insights into crops' health, growth patterns, and potential issues. They can also be used for tasks like spraying pesticides and fertilizers, improving efficiency and reducing labor cost. IoT also enables livestock monitoring. Sensors can be used to track the health and behavior of livestock, providing real-time data on their location, activity levels, and vital signs. This allows farmers to identify potential health problems early and improve animal welfare. Finally, we have smart greenhouses. IoT-enabled greenhouses use sensors and automation to control environmental factors like temperature, humidity, and light levels. So this creates optimal growing conditions for plants, leading to increased yields and reduced resource consumption. In conclusion, IoT is transforming agriculture by enabling data-driven decision making, improving efficiency, and promoting sustainability. So these applications are helping farmers to produce more food with fewer resources, addressing the growing global demand for food. Now we are going to explore the transformative impact of IoT in the healthcare sector. So this slide highlights key applications of IoT in healthcare, showcasing how technology is improving patient care, efficiency, and overall health outcomes. Healthcare is a critical domain where IoT is making significant strides, enabling more personalized, proactive, and efficient care. The first application is remote patient monitoring. This involves using wearable sensors and connected devices to track patients' vital signs and health data remotely. This allows healthcare providers to monitor patients' conditions in real time, detect potential issues early, and provide timely interventions, especially for chronic conditions. IoT also plays a crucial role in promoting hygienic hospitals and clinics. The sensors can monitor environmental conditions like temperature, humidity, and air quality, ensuring a safe and hygienic environment for patients and staff. And another important application is depression and mood monitoring. Wearable sensors and mobile apps can track patients' activity levels, sleep patterns, and other indicators of mental health. So this data can be used to identify potential signs of a depression or mood disorders and provide early interventions. Finally, we have pharmaceutical temperature monitoring. IoT sensors can be used to track the temperatures of medications and vaccines during storage and transportation, and this ensures that these products are stored at the correct temperatures, maintaining their efficacy and safety. So this image provides a visual representation of a wearable wireless body area network and its connection to the broader healthcare system. You can see various wearable sensors such as an airworm temperature sensor, pulse oximeter, and ECG monitor collecting data from a patient. This data is then transmitted to a local controller, a cellular phone, and ultimately to a database for medical and healthcare data management. And this diagram also shows the connection to a medical institution, a data analysis system, and a healthcare management system. And we are now going to delve into some of the foundational tools and platforms that make IoT development possible. The slide highlights two popular options, Raspberry Pi and Arduino. These platforms are widely used by hobbyists, developers, and professionals to build and prototype IoT devices and applications. Let's start with the Raspberry Pi. As you can see, it's described as a low-cost credit card-sized computer. This means it's a fully functional computer that can run an operating system similar to your desktop or laptop. It plugs into a computer monitor or TV and uses a standard keyboard and mouse. This makes it incredibly versatile for a wide range of IoT projects. The image here shows a Raspberry Pi board with its various components including the processor, memory, and I/O ports. You will notice the 40-pin GPIO header, which stands for General Purpose Input and Output. These pins allow you to connect sensors, actuators, and other electronic components to the Raspberry Pi, enabling it to interact with the physical world. And now let's look at Arduino. Arduino is described as a prototype platform, and it's an open source based on an easy to use hardware and software. It's designed to be a simple and accessible, making it ideal for beginners and rapid prototyping. The image here shows an Arduino microcontroller, and it consists of a circuit board that can be programmed and a ready-made software called Arduino IDE. The Arduino IDE provides a user-friendly environment for writing and uploading code to the microcontroller. Now let's take a look at the significant economic impact of this technology has been generating. This slide highlights the growth of the IoT market based on the Gartner survey. As you can see, the economic impact of IoT has grown sustainably over the years. In 2014, the market was estimated at $2.3 billion. By 2016, it had nearly doubled to $4 trillion. Just 2 years later, in 2018, it reached $5 trillion. And by 2020, it had surged to $7 trillion. And now it will be $10 trillion. This demonstrates the rapid expansion and increasing adaptation of IoT technologies across various industries. These colored cylinders provide the visual representation of the growth trend. Each cylinder corresponds to the specific year and the estimated market size in trillions of dollars. The increasing height of the cylinders usually reinforces the significant growth on the IoT market. At the bottom of the slide, you will see the logos of several key players in the IoT space. Cisco, Huawei, GE, and Texas Instruments. So these companies are heavily involved in developing and providing IoT solutions, contributing significantly to the market's growth. Their involvement highlights the industry-wide commitment to IoT and its potential. It's important to note these figures are based on Gartner survey, a reputable source for market research and analysis. This adds credibility to the data and underscores the reliability of the economic impact estimates. And that's all about this presentation. And thanks for watching. Thanks for listening. Thank you.